Hey everybody, this is Limits and Derivatives Unit. We're on video 9 and we're going to be talking about extrema, which is a fancy word for maximums and minimums. So let's go ahead and get started. You need your worksheet with you along with your graphing calculator because we are going to be using our graphing calculators on this, so make sure you've got those with you as well. All right, so the first four graphs that you have here, I'm going to do a few of them with you. I'm actually only going to leave one of them for you to try on your own, just because they're all a little bit different. And what we're going to be looking here for is actually all of our maximum and minimums. But more importantly than just pointing them out, which is the direction says just circle and identify as whether or not they're maximums and minimums, is we're actually going to be talking about what it means to be a maximum or a minimum. And that's going to travel over the next couple days. But the truth is that I'm going to have all of these tangent lines that we've been working with, and we'll have these tangent lines on all the sides of our curves. And it's when the tangent line is actually horizontal that we have what is considered a maximum or a minimum. So these are important values to us as we progress through this unit. So we do have a maximum up here, and since I don't have any increments or any units on my x and y axis, we're just really just pointing out where they occur. But they occur whenever we have the tangent line to be horizontal. So when a tangent line is horizontal, we actually have the slope equal to 0. So that's kind of cool because we can determine whenever the slope equals 0, which we know how to calculate. As soon as we find the slope equal to 0, we actually have identified something really important without even having a picture of our graph. We know automatically that must be something important like a maximum or a minimum. So on this particular function, all we were looking for is where's the max and where is the minimum. So that is as much as you have to do, but this is a bigger picture that's super important to us. All right, so I'm skipping number 2 because I think you can find that, and be careful on number 2. There's more than one max and min going on there. And here we actually have a maximum here, but we have another maximum here, and then I'm going to change colors. We're going to get red is going to indicate our minimums, which both of these are minimums. Now, why does this have a minimum at the end? Well, it's because of just that. We have maximum and minimums located because this function stops. It doesn't go on forever. So we actually have to consider those maximums and minimums, okay? Now there's something special about that because it is over a closed interval where it isn't going to infinity or negative infinity. But it's different than like numbers 1, 2, and 4 because it doesn't have arrows on the end. So we do have to consider those maximums and minimums as well. So we can actually separate those by talking about absolute max and min or relative maximums and minimums. So those are some different terminology that you'll see. Absolute means it is the highest place on the graph, or it is the lowest place on the graph. And then our relatives are, well, it's important because it spikes up to this spot, but that doesn't mean it's the highest. All right, so we have something else unique happening over here on number 4, and please ignore all of this extra stuff that's going on. I don't even know if I can get rid of it on here. Oh, look, I can use a white ink and erase it for you, but I mean, it erases mine, not yours. Okay, so let me grab a color now because that was useless when I go to try to tell you anything. So here, if I'm looking, I may consider that there might be something going on in here, but the way the picture looks, I really can't identify anything. So I'm going to say that down here we have a minimum. Now I'm not going to say that these arrows are leading to any sort of maximum because they are going on forever and we can't identify infinity. So we actually just will on this picture identify a minimum. So make sure you take a look at number 2. Shouldn't take you more than a couple seconds to answer that one. At this point, make sure you have your graphing calculators with you as we continue on to the back side of the worksheet where we're going to be really calculating these values. All right, so I'm going to do 7 and 5, and that means that I'm going to be leaving number 6 and 8 for you to try on your own. And we're going to start by entering this into your y equals. So you do that, I will do the same. And And if you want to, go ahead and look at the graph so you can kind of see what you're looking for here. And I see that you do not have to sketch it, but it might give you an understanding of where we're headed. And I get something like this. So I recognize that I'm probably looking for one maximum and one minimum. Those two spots right there. Well, to do this, I'm going to take a few steps. You may remember this from Algebra 2. It's going to be no different than that. And that is that I'm going to be using the functions of second trace, which gives us our calc menu. And under calc, I want to choose max or min, depending on which one I want to do first, which is number 3 or number 4, whichever one you want to do. I guess I'll do the maximum first because it's the one most to the left. Okay, now what you have to do next is you have to take, I call it the little frogger, it's the blinker guy. You must use the left and right arrows only in order to get on either side. So I want to put the arrows on these two spots, and it says at the bottom left bound, right bound. Well, that's what you're searching for. So I move the frogger guy over to the left side and I hit enter. It's just the left side of that location. And then I go to the right side and I hit enter. And then it asks you to guess. Doesn't really matter where you guess. What you've done is you've narrowed the calculator down to say just kind of look in between these two little areas. Okay. Well, what I'd like you to do now is I'd like you to round to I think I said 10th place on the worksheet. So make sure you're rounding appropriately. And it says that I have a maximum at -1, 5 is what mine shows up at. So there's my maximum right there. Now I'm going to calculate the minimum. So I'm going to follow these two steps again, and I'm going to do second calc, but this time I'm selecting number 3, minimum. And I'm going to arrow my little frogger guy over. I'm going to change color so you can see once again. So here I'm going to be looking at this side and on this side. So if you arrow over, I'm on the left, and then now I'm going to be on the right, and you can guess wherever you want. And this time it gave me a minimum at 1, 1. All right, so I have my maximum and my minimum. Using the graphing calculator, I've rounded according to the directions, and I'm ready to go ahead and try the next one. So the next one here, go back into y equals, and I'll enter y equals x to the 4th plus 2x cubed. I'll take a look at the picture. And I can see that this picture kind of reminds me of number 4 on the front page. So if I'm not sure what it looks like, I might want to zoom in. Okay? When you zoom in, you have to hit enter when you're on the graph page. So I'm going to zoom in, and then I'm going to hit enter, and it'll give me a little bit better of a picture of what I should be looking for, because maybe there is a maximum there, maybe there isn't. So I've got sort of that picture that looks like the first page here, like this. Looks very similar. So I definitely can see that I have a minimum, so I can go ahead and use the second calc, or second trace, and find my minimum. I'm going to put the little frogger on either side of that. Kind of looks like Rudolph. I'm definitely not an artist. All right, left bound, move over to the right side, right bound, guess. And it looks like it comes up at a minimum, if I'm rounding correctly, -1.5 comma, -1.69, if I'm rounding according to the directions. If not, change that for me. And now I want to see if there's actually a maximum around here that's just hard to see. So to do that, again, I'm going to use second calc, choose maximum, and I'm going to arrow over to what I think is the left side, which kind of looks negative. And then I'm going to go to the right side, it might be, and then hit enter again. And it does tell me that I have a maximum. It's really, really hard to tell. You might want to zoom in one more time, but my maximum here is 0.05, comma, and that number that you get, mine, it might show up different on yours, 3.09e to the -4. That actually represents a number that is like 0.000309. Okay, it's practically 0. Your calculator's not rounding very well for you. So I got a minimum here and what I think would be a maximum right in the center. If you're having trouble with this part of it, we can definitely work on that one together in class. So I've left you to try number 2 on the front page and number 6 and 8 on the back page. The idea of this is that you understand what are maximums, what are minimums, and how we can find them in the graphing calculator. That's it. Oh, I don't need to summarize it. I think you got it all.